That's okay. So for clarification, and today is the 20th, and this is being recorded, when we're talking about the mass times acceleration and force of gravity. So when we're dealing with an object, and we've decided that, okay, the motion on the x-axis, sum of forces on the x equals 0 because there's no acceleration on the x-axis. So that's 0 if mass times net acceleration is equal to 0. Well, all objects have mass. So we're not talking about objects with 0 mass here, but we're talking about things for which this is 0. And we've been very quick to go, oh, okay, no motion on the x-axis, that's 0, we're done. And in most of these problems, we're dealing primarily with things that are moving on the y-axis. So we've been saying, oh, well, okay, sum of forces on the y equals ma net, and that equals force up plus force down. What we're doing here, and I've skipped a step, which I think may have been confusing, what we're doing here is we're actually saying that the sum of forces on the y is equal to two different things. So sum of forces on the y is equal to the mass times the net acceleration. That's not gravity. That net acceleration is the acceleration that the object is experiencing. Might be less than gravity, might be more than gravity, but it's the acceleration that it's experiencing. The other thing that we're saying, and this is a separate idea, is that the sum of forces on the y in these problems is equal to the force up plus the force down. So these are two separate ideas, but because the sum of forces on the y is equal to both of these things, then guess what we can do? We can set them equal. So what we're really doing is saying, oh, well, ma net equals the force up plus the force down. So that's really what we're doing here. Now, in a case like number 2, part A, we're told that this is 0. So we're back to the kind of problems we had in the 4A problems, where the thing wasn't moving or was moving at constant velocity, where it didn't have a net acceleration. But more commonly in these problems, we're looking at something where an acceleration does exist. And so if this is not 0, then we have that. And this force up can be a number of different things. It can be a normal force, which we're going to talk much more about in the next section, but normal forces are exerted by surfaces. So if it's sitting on a table, a floor, a stump, another book, whatever, that's a normal force. The other thing that forces up typically is force of tensions. If it's being pulled by a cable or a rope, or a spider web, or a gob of bubble gum, whatever, that's a force of tension. So these are typically either a force of tension or a normal force. The force down is typically one thing, Fg. And the force of gravity is equal to mass times gravity. Don't confuse this with this. They're different. This net acceleration is not gravity. It doesn't bear a relationship to it. Okay. So, that if you're given mass and you're given net acceleration, you have the tools you need to find, a force up. If you're given the force up and the mass, you have the tools you need to find net acceleration. Does that help? Does that clarify anything? Okay. We'll pause it and keep working and